Alright, we are here on the Jupyter dashboard, and by default this is a view on our users folder or home folder on Macs. And here I can find the folder baby that I created before in my users folder. And here in this folder I saved the downloaded zip files and also the unzipped files. And first of all, let's go to the national dataset names. And here we can find all text files, all 136 text files from 1880 until 2018. And I also created 2 Jupyter notebooks, one for case 5 part 1 and one Jupyter notebook for case 6. And as we have the Jupyter notebooks and the text or CSV files in one folder, we shouldn't have any problem to import the text files into pandas with pd.read CSV. So now let's do this. So we go to case 5, importing babies, part 1. And here in this lecture, we will import only one file. So for instance, for the year 1880, and we try to understand the data structure. So first of all, we import pandas as PD, and then we can import the year of birth 1880 text file with pd.read CSV. So let's create the data frame and let's simply have a look here. And these are actually the names in 1880, and the most popular name for females was Mary, with a total count of 7,065. Then second we have Anna, then Emma, and so on. So F stands here for female. And finally at the bottom we can see some less frequent male names, Woody, Worthy, Wright, York, with a count of 5. So in the datasets here, we have only names with a count of at least 5, and the names with a count of less than 5 are actually dropped. So they are not included in the dataset. And we can also see that in the year 1880, we have almost 2,000 different names. And we can also see that our datasets do not have any column headers or labels. So it's simply starting in the very first line with the first name, Mary. And actually it might be a good idea to create column headers or column labels. And we can do this with pd.read CSV, and there are the parameters header and names. And first of all, we have to pass none to header, and by doing so we actually tell pandas that there are no header or column labels in the dataset. And then we can pass our desired column labels. And for the first column, it should be the name. Then for the second, the gender. And finally, in the third column, the column header should be count. So that's the number of occurrences, actually. So let's again create the data frame with the right column labels or column headers. And let's save the data frame in df. And let's inspect df. So now we have here the column labels, name, gender, and count, and we are starting here at index position 0 and also row label 0, and we have here a range index, and we are starting with the very first name, Mary. And of course we can also get some meta information with .info. And here we can see that we have 2,000 rows, so we have 2,000 different names. And we have 3 columns and actually no missing values. And also the data types make sense. So we have text data in the name and gender column. And we have integers in the count column. So that's the data structure here. And in the next lecture, we are going to import the data for all 139 years. And we try to merge the data in the most efficient way. So thanks for watching, and see you in the next lecture. Bye. In the last video, we have imported the names data set for 1 year, and now in this lecture we are going to import all 139 datasets, and we are going to merge all datasets into one data frame. And the plan is to do this in the most efficient way, and I call this case here the easy case, because all 139 datasets are stored in text files with file names that follow a very simple pattern. And later, when working with the names data set by states, this is not the case, and it's getting a bit more complicated. So let's have a look at our folder and the pattern in the file names. So we're starting with the year of birth, and then we have the year, and finally dot text. So that's the very simple pattern here. And we should be able to easily handle this with a combination of a for loop and a string replacement. But first of all, let's focus on 2 years and 2 data sets to figure out how it could work. And we import pandas, and then we import the year 1880. So we create the data frame df 1880. So this is nothing new. And then we also import and create the data frame for the year 1881. And also 1 year later, Mary is still the most popular female name. And now we can actually concatenate both data frames with pd.concat. And we can pass a list with both data frames, df 1880 and 1881, to the objects parameter, and we actually want to concatenate the data frames vertically. So first of all, we have the rows of the first data frame, and then the rows of the second data frame in one data frame, and therefore we pass 0 to the axis parameter, which is also the default argument. So let's have a look here. And here we have a data frame now with almost 4,000 rows. So we have the rows of 1880 and 1881. And we have actually 2 problems here. So first of all, it's hard to identify whether a row is coming from the first or the second data frame. So we do not have the particular year here in the data frame. And second, we can see on the left-hand side that we have the original row labels, so this is not a range index anymore. And we can see this here at the very end. So in total we have almost 4,000 rows, but the row label for the very last row is still 1,934, so it's here right. And we can see the same row label here for right also in the data frame 1881. And actually, it doesn't really make sense to have duplicates here in the index. So we should clearly enumerate the rows from 0 till almost 4,000. Now, first of all, let's focus on the first problem. And we should actually add the corresponding year to each and every row. And we can do this with the parameter keys. And with keys, we can create a multi-index here and add an outer index level with the corresponding year. And we can actually define the row labels for the outer index. And first of all, we open here a list. And actually for the first data frame, we want to have the label 1880. And for the second data frame, of course, 1881. And now let's again run the cell here. So now we have here a multi-index with the outer index level that we created with keys and the inner index level. So this is again the original row labels. And then in addition, it could make sense to give here an index name for the outer index level, for instance, year. And we can do this with the parameter names. And here we can pass our desired index name within a list. So it should be year here. And let's again run the cell. And of course, I forgot here the equal sign. So let's do this. And now we have here the outer index with the index name year. So now we have solved the first problem. And now let's come to the second problem. So the inner index level does not really make sense. Here we have the original row labels and we have many duplicates. And therefore, so let's cross this out. This is actually the same here as above. And now we can drop the inner index level with the drop level. And we have to select the level. And here the most right on, or the inner index, is at position -1. And here we simply drop the inner index level. And finally, we can then reset the index and create a range index from 0 till almost 4000. And we can actually transform the year index here into an ordinary column. So this definitely makes sense. And now we have here a range index, and we have the column year. So that's the hands-on approach that works pretty well in case we only have 2 or 3 data sets, but it's definitely inefficient with 139 or even more data sets. And therefore we have to find a solution here, and the solution is a for loop and a string replacement. And first of all, let's recall string replacements. And again, we want to import the year 1880. And instead of having here 1880, we introduce here a placeholder. It's with the curly brackets. So that's the file name as a string. And then we can use the string method format, and we can pass actually the replacement value. In our case, it's 1880. And the curly brackets here are getting replaced by 1880. So this is a very simple example for one data set. And also here we get the data frame for the data set 1880. And again, this is called a string replacement, as we replace parts of the string. And in combination with a for loop, this is really powerful. So now we want to create a for loop that iterates over all years from 1880 to 2018. And therefore, first of all, we create a list the years with numbers from 1880 to 2018 inclusive, or 2019 exclusive. So let's run the cell here, and let's create the list the years with elements from 1880 until 2018. And now we can create a for loop. And first of all, we create the empty list data frames, where we will store all data frames, all 139 data frames. And then we iterate over the list the years. So for year and years. And for each and every year, we create the data frame and save the data frame in the variable data. So here we have the string replacement. And we replace the curly brackets for each and every year by the particular year. And then we append for each and every year the data frame, the resulting data frame, to our list data frames. So let's run the cell here. And let's reinspect data frames. So this is a list, and each and every element of the list is a data frame. So the first one for 1880, the second one for 1881, and the very last one for 2018. And we can also check the number of data frames with the length function, and it's no surprise it's 139 data frames. And then finally we can pass the data frames list to pt.concat to the objects parameter. And again, we vertically concatenate all data frames, and we pass years to the keys parameter. So the very first data frame in data frames get the key 1880 and so on. And also here we give a name to the new index level. And finally we drop the inner index level and we reset the index. And we actually create the data frame df, and let's inspect df. So here we're starting with all rows and all names in the year 1880. And finally, at the very end, we have all rows and all rows of the year 2018. And in total, we have almost 2 million rows, and each and every row stands for a combination of name, gender, and year. And we can also get some more meta information with info. So we have almost 2 million rows, 4 columns. And we actually have integers in the year and also in the count column. And we have a memory usage of around about 60 megabyte. Alright, this was the easy case how to import and merge many text files into one data frame. And in the next lecture, we will have a look at the more complex case. So thanks for watching, and see you in the next lecture. Bye. In the last lecture, we have merged all years into one data frame, and now we should export and store the dataset somewhere. And one solution could be to store the dataset locally on our computer as a CSV file. And we can do this with the method toCSV. And then we can define the file name usbabynames.csv. So this is a CSV file. And then we should pass false to the index parameter. So here we have a range index, an ordinary range index. And we should actually drop that index, because when we re-import the data from the CSV file, then pandas automatically creates a range index. So let's have a look. And first of all, let's create the CSV file usbabynames. And we can also check whether we have the new CSV file in our folder. And now here we can see the CSV file usbabynames. And now we can re-import the usbabynames with pandas and create the data frame. And as I said, so by default on the left-hand side, we have here a range index, and still we have the columns year, name, gender, and count. And now we are prepared for explanatory data analysis, so we can simply import the usbabynames CSV file. But first of all, in the next lectures, we will cover a more complex case with the names by state. So thanks for watching, and see you there. Bye.